Okay, homework chapter 4.17. Let's look at how to use the 16-bit timer. And what we want to do is create a subroutine that creates a 1-second delay using that 16-bit timer. And we need to include both an initialization ritual and the delay function. So we can start with the 16-bit timer that's on page 138. And there's a few instructions that we have to put at the beginning and the end in order to try that out in Texas. So let's do that. I've already got the program entered in here, but let's take a look at what it does. The few things that we had to add. So a few equates. The TSCR, the timer control register 1 is at 46, and control register 2 is at 4D, and the T counter itself is at 44. So we'll want to monitor that 44 location. So I'll go ahead and put that in the microcontroller window as well and display it in decimal format because we're going to be counting up to 1,000, and we can display that in decimal format. So we need our familiar org statement, and we need a main, an entry point for the program. And here we're going to initialize the stack, and then we're going to call the initialized program. And then we're going to load 1,000 into the Y register and call a subroutine called timer wait Y milliseconds. In the book example, he called it wait 1 millisecond, which I found a little confusing because it actually waits the number of milliseconds that's in the Y register when it's called. So that's why whatever's in Y, you load 1,000, call timer wait, and then decrement Y. So you have to have Y initialized when you come into this routine. And the timer init function initializes the timer by setting the timer enable bit and then loading 03, which is a divide by 8. So this will give us a 1 megahertz clock frequency for our timer. So let's go ahead and run this thing from the beginning. Let's clear this out, and we'll reset. And so the timer is initially 0, and all our registers are 0. And when we run the first instruction, we initialize the stack pointer. Then we branch subroutine to the timer init function, which turns on the timer and then turns on the divide by 8, turns it into a 1 megahertz. But one thing to notice is the timer is actually already running. It's in the time that it took to execute those few instructions, it's simulated 14 cycles, but it's running at the faster rate. We've just now executed the divide by 8, so now it'll be running at 1 megahertz or 1 microsecond, where before it was running 8 times that fast. So you'll see it not move as much now, but it is already running. I guess by default it's enabled in this simulator. So then we return from the initialization routine, and we load 1,000 into the Y register. There it is. And then we branch to the timer wait Y milliseconds routine. So we're going to load the D register with 1,000, and then we're going to branch to the timer wait subroutine. And what it does is it reads the T counter, which is currently at 16. It adds that to whatever's in the D register, 1,000. And so now we put 1,016 in the D register. And that's what this routine is going to do. It's going to keep comparing, it's going to keep reading the timer and comparing it to 1,016. So it's currently at 16, and it's going to wait till it's 1,016. So in other words, it waits 1,000 microseconds. So let's go ahead and run to the return statement here. This will have to execute 1,000 times. There's a place up here where you can change the simulation speed, and I've got it set to fast so it doesn't update this screen quite as often, and that speeds it up a little bit, but it'll finish here shortly. And there we are. It has now completed 1,017. Well, it didn't do that many loops. It looped as many times as it took for the T count to asynchronously, on its own, change to 1,017. So when it exits this subroutine, then we can go back to decrement the Y counter. We're at 1,000, and so now the decrement to 999, and it'll repeat that same thing 1,000 times. So that's how the T counter can be used to generate a time delay. And we did a couple levels of subroutines in here, and the only confusing part from the way that this code is structured is we've got one subroutine calling another subroutine, and you have to be sure and that works fine. You just have to be sure to load a value in y before you call that timer wait y milliseconds, so it knows how long to wait. And that is how you solve homework problem 417.